Hello, in this video we're going to be creating a image classification. Here is the dataset. There are others as well you can choose from, as you can see, and we'll share the link in the video below. So now let's iterate over it. We see it's successful and we continue. Now we have to go through the category. Here it gives me suggestion. So we go through OS, list there. We get the train path. Now num category names, len. We get the number of category names, train images, category, and look through them. Of the categories, we define a folder and have we assign the existing train path together with the category. We'll list there and get the folder of it. And for the sake of it, let's just display it in a bar plot. Category names. Train images. And just let's set the title. Train set. Now let's run it. And you can see we defined female as blue one and male as orange. Now we can see them both being displayed. Male being a little bit more predominant with the test files. It's totally fine. So now let's create a test images. Empty array, category, in category names. Append OS list there. Append same logic. Bar plot. Select. Category names. Oh, I missed something. I never defined a folder. It has to be redefined here. Oh yeah, because it has to go through the test path and append the category again. as you can see here, and through the listed folder. Now we can see the category between these both. Okay, let's see if actually the image is being showcased. So it's you can see this one is from training set. You have the male, and I think it should be the first one. So the pictures being loaded is needed. So now let's define the training. Now that this may actually take quite a while due to the sheer number of files here. So define the path. We go one level deeper. So now we have to use the image library. Open. So I have to convert it to now. So here we have to actually resize the image for it to be able to incorrectly. Define NPS array. Oh, 38 seconds actually not that bad for train the male data. It's a training male data set. So here actually they have to be concatenated x0 instead of x label. So now let's just print them. How much are there overall with NP shape? So woman face is 23k. Both are relatively the same. Train dataset values, so shape and the validation. Now the testing will be quite similar to this one. Is it define as well a label? So the logic is actually quite similar as last time, so I think I'm just gonna copy paste it. You can see it doesn't actually differ a lot from this one. As well, main face, resize comfort L, resize. So you can see it's like same code. The only difference is here is like have the training set, and here is a test set. The logic's basically completely the same, but we have to be able to compare from the test set and the training set. And training set we have defined in the beginning. And here, as you can see, we concatenated both male and female into x0. So this is train as label, we pass in the label. Y train is Y train has to be reshaped for it to be applicable to train. The array format. Now this one takes like over a minute because it's actually both of because here I divided them. Should be finishing shortly. I just took around 2 minutes, totally fine. As you can see here, the validation set is a lot less, but still it's like 70-30 basically. Done as before concatenation. I'm just gonna actually make a shape. Use the shape of it. New line. Y shape. Format. X. Everything seems. Now we're gonna import a different library, which has actually been done in the top level, but just do this. And now we define the training itself. So X, because here it's like was to set it in the right array, and then to concatenate and so forth as array. So now x train x just y train y test train test flip from sklearn. And now I'm gonna define x, y. We have added them here, x, y. Though x, y from this case is the testing set, and now we're gonna add as well test to resize. Oh no, test size 0.2. Just as you can see here, split arrays and matters into random train at the subsets. Now random state 42. Right? That is done. So now initialize bias def initialize dimension w equals np for I don't need this one. Dimension 1 0.01. This sigmoid is part of the, to have the calculation done using exponent. Let's run it, should be done quite fast. There's quite a lot of writing, so I'm just gonna copy paste and shortly go through it. This is like some kind of propagation class direct weight. So now we have the prediction. I'm gonna add it. We basically predict based on inputs. We test head prediction and p0s. So it's basically if it's bigger than 0.5, then it's Yeah, then it's male, I think, 0. And if it's opposite, as you can see, if it's actually Y prediction is too closer to certain sense, then it's gonna be a female prediction. And here we can use logistics regression for it. We pass in the data, learning rate, num iterations. As you can see, it's being passed in here. We fit the model. We use logistic regression. And here, as you can see, we check the accuracy score, and test score. Here we can use like predict. We open a random image, set up the dimension, and as you can see, it's set to 1 as male. And otherwise, you can as well save it in a pickle for other cases, as I did here. I actually get the pickle load, and in the GUI I load the get the image, I classify, and I put in the training model. So I hope you like the video, and see you in the next one.